Hey there, buddy. Now this is a fun one, a beautiful problem with a twist. The idea is clear at first glance from the diagram. We've got three circles here, blue, green, and red. Each pair of circles touches externally, and all three also touch the same straight line. The blue circle is the big one, with a large radius r. The green one's tiny, with a small radius r. And the red circle, well, that's exactly what we need to find. Now, sure, you could dive into algebra, juggle the Pythagorean theorem back and forth, and fill half a screen with calculations. But why suffer when there's a beautiful geometric approach? So hit pause on the video, try to solve it yourself, and then come back. If you come up with your own method, share it in the comments. I'd love to read it. Academic bit of theory. Before we tackle the red circle, let's look at a classic setup. Two circles that touch each other externally and both touch the same straight line. Between the points where the circles touch the line, let's call them A and C. We can find the distance, i.e., express the length of segment AC in terms of the circle's radii. Spoiler alert, this trick often comes up in the Russian Unified State exam, so pay close attention. Important to remember, if you connect points A, C, and D, where D is the point of tangency between the circles, you get a right triangle. And you get another right triangle if you connect the centers of the circles and the midpoint of segment AC. Why right triangles? Well, want a challenge? Try to prove it yourself and post it in the comments. Let's see who the real geometry geniuses are. Now, to the point. Let's label the midpoint of segment AC as M. Then DM is the median of triangle ADC. And at the same time, it's the height in another triangle, O1, O2M. But the height dropped from the right angle in a right triangle equals the geometric mean of the projections of the legs onto the hypotenuse. So DM equals square root RR, which means AC equals 2 times DM, which is equal to 2 times the square root RR. Now, let's go back to the original problem. Segment AC is made up of two parts, AB between the blue and red circles, and BC between the green and red circles. We already know that the length of the external tangent between circles with radii r and x, where x is what we're solving for, is 2 times the square root rx. And between circles with radii r and x, 2 times the square root rx. Add them up. AC equals 2 times the square root rx plus 2 times the square root rx. Now simplify. Cancel out the 2's, rearrange things, and boom, you've got the formula. Nice and clean. No messy formulas, just elegant reasoning. Target. If you liked this approach, hit that like button, subscribe to the channel, and don't forget to check the comments. You'll find a link to our Telegram group where you can discuss, share your solutions, and learn with others in a fun way. We're getting ready for the Unified State exam, EGE, and Basic State exam, OGE. Not just effectively, but with real enjoyment. See you soon, Geometry Genius!